Hi mathematicians, we are going to go over another method for solving for limits. This time we're going to use some trig identities to manipulate some relationships or manipulate some functions into something more manageable. So here we have our problem limit as x approaches 0 of sine squared x over 1 minus cosine x. And we can see clearly if we plug in x equals 0 here, right, my x coordinate at 0 degrees, that's what we're talking about in this situation, is 0 degrees, right? So our x value at 0 degrees is 1, and so we end up with 1 minus 1, which we don't like. It makes us very upset. So what can we do? What are our choices here? And so one choice that we have is to try and manipulate this in some way so that we can, cross some things out there. So let's go ahead and look at, if we remember, does anyone remember sine squared x plus cosine squared x equals 1? What is that? That is the Pythagorean identity. Do you remember that one? We're going to use this to go ahead and plug in for the top here. Okay, and so I'm going to solve for sine squared x. So I get sine squared x equals 1 minus cosine squared x. And so I'm going to go ahead, like I said, and substitute in the top, and I get 1 minus cosine squared x over 1 minus cosine x. We see that the top is a difference of 2 squares. Yes, you do. You see that. Okay, 1's a perfect square. This is a perfect square. Let's go ahead and factor it. Okay, so these are going to go ahead and cancel. We're left with the limit as x approaches 0 of 1 plus cosine 0. What does that equal? Well, that equals 2, because cosine 0 equals 2. Okay, let's go ahead and do one more. So we have the limit as x approaches 0 of 1 minus cosine 2x over sine x. And we know that the sine at 0 is 0, right? The y value here, right? Sine is the y, cosine is the x. But instead of reading the x values left and right, we're reading the degrees, right? So we're looking at this position right here is when x equals 0, and our cosine is 0, excuse me, our cosine is 1, our sine is 0, right? We don't have no elevation in either direction. Okay, so this would be 0 on the bottom here, right? I'll even draw us. Let's draw a sine curve, right? This is my sine x curve. At 0, we're at 0. Okay. So what are we going to do? Let's see if we can manipulate this in some way. And so look up our double angle formula. And so cosine 2x equals cosine squared x minus sine squared x. And so let's go ahead and use that and see if that's helpful at all. So we're going to change this to the limit. And sometimes we try something and it's not helpful, right? Sometimes we try something and it's like, oh, that's wrong. That didn't get me anywhere. This didn't help me. And that's okay, and you have to go back and try something else. So if I do this, what am I left with? And sometimes you don't see what's going to happen until it's already happened, right? We're going to do minus cosine squared x plus sine squared x over sine x. And if you remember from up above, we already found out or figured out that sine squared x equals 1 minus cosine squared x using our Pythagorean identity. So that means I can come down here and I can substitute in for this. I can sub in sine squared x. So this becomes the limit as x approaches 0 of sine squared x plus sine squared x over sine x. This becomes the limit as x approaches 0 of 2 sine squared x over sine x. The limit as x approaches 0 of 2 times sine x equals 0. Got a little carried away, sorry. Didn't show all the steps. Okay, so what did I do? I substituted in here for sine squared x. We knew that because of the Pythagorean identity. That gave us 2 sine squared x's. And then, of course, this is just 2 times sine x, right? That's what that equals. So I just went ahead and canceled one of them with one of those down there. You end up with 2 sine x. What is our y value at x equals 0 over here, if we're looking at the unit circle? Right? What is our y value if we're looking here when x equals 0? Right? 0 in both regards. The limit as x equals 0 of 1 minus cosine 2x over sine x equals 0. Okay?